My goal is to make this the shortest video I've made. And so that might just happen and I might just stop talking so that I can meet my goal because I like to win. But here goes. I'm going to be graphing with derivatives. I don't think I'm actually going to graph in this video. We'll see what happens, how I feel. It's all vocabulary. So remembering that a derivative is a slope at a point. If you can remember that, and this is going to be so fine. So if somebody says to you that your f prime of x is positive, greater than 0, f prime greater than 0, what does that mean about your function? So if your slopes are positive, your function is increasing. That is the word you need to use. Please don't say going up. The word is increasing. If somebody says to you f prime is less than 0, then you would say that that means f is decreasing. And I guess I shouldn't put arrows one way, like we can go back and forth. These all mean the same thing. So if somebody gives you this information, then you need to be able to go the other way and tell me what that means about the derivative. So you need to be fluent both ways. All right, that's all well and good. Increasing means that, decreasing means that. And if I asked you to draw a function whose first derivative was positive, but then it turned negative, you would draw a function that is increasing and then decreasing, and you would think it was the best day of your life. But there's more to it. So what if you find out your second derivative is positive? Your second derivative is negative. Second derivative. Okay. Well, you know what a derivative is. A second derivative are the slopes of your slope. So if a derivative is slope, the second derivative are the slopes of the slope, the rate of change of your slopes. It's how your slopes are changing. And your mind is boggled, I know. Here are the words. If your second derivative is positive, that means your first derivative is increasing. It means your slopes are increasing. Well, if your slopes are increasing, it means your function is what we call concave up. I will show you what that looks like in just a second. Same idea down here. So you're smart enough to manage this. I think decreasing, and then f is concave down. So let me draw you. Concave up can look like two different things. You can be increasing and be concave up, or you can be decreasing and be concave up. But do you see that cup it's making, that if I put ice cream in, I could actually eat the ice cream? Versus concave down. I could be increasing concave down, or I could be decreasing concave down, but my ice cream is on the floor. So that's concavity. It's called concavity. More vocab, because that's really all this is about. So we did for first derivative positive or negative. First derivative equaling 0 is something called a critical. We will use that term a lot, so it's good for you to know. Your second derivative equaling 0 is similarly called a hypercritical point. And I think that's all the vocab. So let me show you one last thing. It's so obvious. I feel silly writing it down, but I'm going to do it because I'm thorough. Here comes a squiggle wiggle. I'm not putting an arrow on it. This is f of x. Okay. This point, let's do this one. This point right here is what we call a relative minimum. And if you have the squiggle wiggle in front of your face, it is super easy to look at it and say, oh, look, that's a relative minimum. But the definition of a relative minimum is when f changes from decreasing to increasing. And that is what you called a relative minimum last year with Pickle, and maybe the year before, I don't know. But now that you're in calculus, you can define decrease and increase different ways. So we can define a relative minimum not by what f is doing, but by what f prime is doing. So if f is changing from decreasing to increasing, that means f is changing, not from decreasing, but from negative to positive. So F is changing from negative to positive as a relative minimum, and it's the same thing as F changing from decreasing to increasing. F prime changing negative to positive. You need to be really careful. I think I just messed it up. I'll never know because I'm not watching my own videos. These are not interchangeable. The word decreasing implies a slope. The word negative just means its values are less than 0. All right, so same idea up here. No, oh, I have to, can't not leave that. It's a relative max, and it's when F changes. I have to be thorough. I'm so nervous this is going to make my video longer than I want. Increase to decrease, or F prime changes, writing so fast, positive to negative. That should be fine. I hope that's fine. Don't tell me if it's not fine. I don't want to know. This point. Did you notice my concavity change? So this is concave down because my ice cream is falling out. But now I'm concave up and I get to eat ice cream, which is my favorite thing in the whole wide world. This has a name too. It's called a point of inflection. And a point of inflection happens when your concavity changes. But that's boring. You're never going to be like, welcome to AP Calculus. They're not going to hand you a graph and say, where is its minimum? Where is its You're going to be doing everything in terms of derivatives. So a point of inflection happens when your second derivative changes, and I just say changes sign, because it doesn't matter if it changes concave up to concave down or concave down to concave up. Like that matters with maxes and mins, because one makes a max, the other one makes a min, but points of inflection, it doesn't matter. Oh my gosh, that was all the vocab. I wonder how long this video is. Good luck on homework. Bye.